Hello reviewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about tragedy of trolley process. So let's dive deep into it. So one thing you have to understand is that our world needs public transport, meaning if we continue the way we are continuing, we can simply not grow or thrive flat out. It's not optional, it has to be. We have to have public transport. We cannot use what we classify as personal transport. Physics does not like it. For example, money cannot buy space. For example, one of the metropolitan in India, Kolkata, it's really bad simply because it has way too much population and the road thickness is tiny. Like if you look at it in Google map, you'll be like, whoa, and that creates a lot of congestion. And same goes with everywhere. Of course, some are worse comparatively speaking, but almost all are really bad because money cannot buy space. If you are like, hey, what if I just buy all these buildings and make the road thicker here, still, where would the people go? So context is very real here. Money cannot solve this problem. You cannot just keep making road thicker, because if you did do that, let's say especially for connecting something, you made the road thicker, more cars will fill it up and voila, you are back to square one. So money cannot buy basically space, nor it can solve the problem. That's the first thing. Do not think about money can solve it. No, it cannot. And then we have normal modern hoo-ha of like EVs will solve the problem. No, it makes no difference. Flat out, tangibly, functionally, it makes no difference. The only thing would be your blood pressure would be little bit lower because it will be a bit more quieter if you have this many people trapped in EVs rather than combustion engines. Because again, no emission and less sound, but not too much difference. You still get frustrated because you're stuck in a box. And the traffic's, again, you still have two lanes, so EV does not change it. And another aspect, what if we have self-driving car? It will improve the situation marginally at best. So you have to understand, physics is here. Physics is like, if you pack that many people in a bus, everybody will be comfortably seated, everything would be air conditioned, and it will be just fine. Take that many people, put it in bicycles, still won't take too much surface area. The moment you take the same amount of people and dump it into cars, lol, the space consumption just went lol. So self-driving will not help here. So electric vehicle will not help here. So we have to go into public transport. That's the fundamental requirement of our civilization. Otherwise, we'll choke every large city. Then we come to the ugly part of it, cost. Metros are awesome. There is no discussion about it. Metros are fundamentally awesome, but they require either a time machine, because I have not seen any metro project anywhere on the planet, barring one or two, where it's like, we're going to build this project, it's going to be done in this time. It was actually done in that time. It took exponentially longer, and many times happening places change. For example, if you design a metro and that was like, hey, there was this giant factory, a lot of people are going there, there's this giant hospital, you could take so long to build the damn thing that those things could change. Factory could close down, hospital could shift, happening places could change. So your whole metro network, even though it could be in a densely populated city, may not be utilized. And it has happened to many places, not just one, not or two. Like for example, this is a Kanpur's metro. I had the luxury of going there and driving it. Very cool, very awesome, but nobody was using it because again, it was not connected anywhere. It was in early phases, phase one or so to say. So you need a time machine. You need to build things before it becomes a happening, so to say. So that's the problem. Another aspect is, what if you don't have a time machine? Well, you need infinite budget, because be mindful, that's the only way you can brute force solve it. You just make it, design it, and hope it works. And most of the time it does not. You can look into budgets of almost all metro and almost all of them are over budget, and barring one or two, most of them are running in red. What does running in red mean? Simply means the capital money that was poured into making these things, yeah, that's gone. The running cost, most of the time they are not even making enough from ticket sales that running cost be captured. The optimum scenario is like, realistic optimum scenario is like, you sell enough tickets, enough utilization is there that A, it's not overcrowded, B, it is still giving you enough revenue where it's like running cost is taken care of. Capital, bye-bye the capital. I have not, maybe one or two are there that are like successfully recovered the capital, but most have not. So either you need infinite budget or a time machine. So that's the biggest reason why you don't see growing cities getting metro. And metros are generally done so late, it does not actually save the city. It has to be done before it's too late. Then we come to trams. Like this is India's tram that is being shut down brick by brick, and it has been declared a heritage site because this puppy is 150 years old. Not even making that up, 150 years old. but they had to go through traffic, and there was this very weird time period. This was awesome. It was very successful. India actually had multiple tram system. Calcutta was like surprisingly successful. That's why it was hanging around for so long. But there was a time where fuel prices were so low that if you can afford to buy a car, fuel cost was like nobody cares. Like nowadays, fuel cost is important. Like if you are using a car regularly, you will find that you spent actually more on the fuel rather than on the vehicle. So that was not there. So people could, if they could afford the car, they're like, what if I drive the car all the time? This was like, this is super cheap comparatively back in that day. Nowadays it's cheap just for because they did not bother to update the tickets. It's like, it's already running in negative, and government wants to shut it down brick by brick because too many people are complaining about the congestion. So that in that zone, they did not upgrade these things. That early 90s boom, they did not upgrade this. The tram literally remained the same designs from 1970. Consequence, it literally fell out of favor. People who would have used it were like, dude, might as well go with a car or a bus. Consequence, it went poof. And it also costs a lot. So even though India was not very successful metro is a successful thing. It is successful in Paris metro, and Tokyo and all that jazz is successful. However, it's expensive AF. It's not as expensive as metro, but it is still expensive. Then we come to the final solution, is that bus, especially for small places. It does have low cost to start. However, the fuel prices makes it per mile traveled expensive, meaning per kilometer that you are traveling, a passenger, you have to pay exponentially more on bus compared to basically tram or metro. The reason for that is metal on metal wheels. If you have a metal rail, metal wheel on that, you'll always find metal wheel on metal rails have such a low basically friction that these can be horse drawn, and that's how it was there. Like the early metros were horse drawn carriages. They were not like combustion engine or electric. They were just horse drawn. So this is the cost aspect. That's why you don't see metro or trams in growing cities where they need it the most, because if you put it early enough, then things grow around it and everything is fine. If you wait before it like overflows, at that point in time, it's too late. So what if we use electric bus? Well, electric bus does come with a very severe penalty known as its weight. It has seriously high weight. I was like shocked to discover how heavy it is. At best case scenario, to give you a big electric bus, at best case scenario, it's 20% heavy. And realistically, don't Google how heavy it would be. Like just don't, just no. To give you another context, electric trucks where they did not wanted to use swappable batteries, the weight was so high that government has to increase the capacity, the legal allowed limit, in order to make those things happen. So let that sink in. The weight is brutal here. Now, what's the issue with that? Well, more stress on your infrastructure, meaning if a government is like, hey, I'm gonna buy hundreds and or 500s of basically electric buses, that means that much overstrain will be put on the roads will break down quicker, faster, and you have to spend more money on fixing the roads. And it also harms the vehicle itself. The vehicle's suspension is directly proportional to its weight. For example, the suspension going into a combustion car is super okay, it's lightweight, it's cost effective, but when you talk about electric vehicle, it has to be robust, strong, to last long enough, or last enough where it is comparable to combustion system, because fundamentally it's heavier. Like you can easily get a competent car in as light as 500 kilograms, half ton, to little bit more, like by the time you're reaching 0.7 ton, you can have a good car to electric car starting at 1 ton, and it can easily go to 1.5 tons. So you have to understand, weight is very brutal, especially electric, if you want to increase the range. So not only your suspension suffers, your stress on the infrastructure that you are paying for is brutal. Then charging it is not cheap, simply because the battery capacity of these things starts at 30 kilowatt hour. That's a lot. Like a lightweight electric car that is designed for daily commute, not for long range, could have a battery bank as small as 10 kilowatt hour. If you can start from there, you can easily go to 33, 50 and 100. 100 is like, I've rarely seen, there are only 1 or 2 cars that go that far up. Electric bus starts at there, meaning the amount of energy, even if you're not speed charging it, will be so brutal, it will look like hyper charging compared to electric car system, meaning the electrical utensils you need to transfer that kind of energy is expensive. Chargers are expensive, and they also have short lifespan, meaning even if you design the bus from the most advanced material, aluminum, you may find it's like, hey, chassis is awesome, motors are awesome, even the electronic circuits, they are awesome. The battery, no sir, I'm out. Battery flat or fundamentally don't last. So that creates a very serious issue. And then we come to the final part. It's expensive. I used to think like, I knew like electric bus would be expensive. Like from electric car, price difference from a normal combustion to electric, it's like high, but it's manageable simply because you will make money in savings. In bus, that's not so much so. Like you will make money in fuel saving, but not by that much. And the capital cost is so high that many times people are like, dude, it's just unaffordable. It's super duper high investment. So it also creates a scenario where you may have the same thing as metro. It's like, yeah, the city upgraded all their bus fleet, but yeah, now it's running in red. We don't see it, so we do not panic about it, but it's still a thing that you have to be mindful about. Then we come to the fire aspect of it. These are Chinese buses, this is British bus, and there is more than enough video for India, Australia, or everywhere you want to look into it. Now, why the heck we have fire here? Well, fire itself is not a bad problem. You can deal with that. We have 1 century of research and development in how to handle fuel fire. Problem is, this is space fire. What does space fire means? Meaning it will not be put out even if you put it in space. Why? It has both part. The thing that is burning, the thing that is allowing the burning. The basically fuel and the oxidizer both are in the same container. It's basically a rocket system. That's why you cannot put it out with basically water. All we do with water is trying to cool it so other cells don't start catching on fire. And then it's like, it's a hell of a hassle and nobody has actual way of putting it out. At least no fire brigade that is active, they can take care of it. Nothing exists. So how can you solve it? Fundamentally, from a public safety point of view, you can introduce different safer chemistry. For example, lithium titanate, LTO cells, or lithium iron cells, LFPO, so to say. Now, lithium iron cells have lower capacity. Lithium titanate again has lower capacity. So you have to give up range. So if this bus is exact same chassis, exact same things, exact same weight, I give you the same bus and you're just like, hey, make the chemistry safer, you will lose capacity, like exponentially in terms of range. Your range can go from 200 kilometers to as low as 75 because of the chemistry, and it will cost more. These things are cheap. Be mindful, these things are exponentially more expensive than diesel buses, and if you want to have safer chemistry with suitable amount of range, you have to use lithium titanate oxides. Those are expensive, even more expensive. And yeah, the only good thing at that point is safe, but it comes back to the same thing. If the system is fundamentally not sustainable, economically speaking, nobody will deploy it. People will deploy it to look cool and all that, but after then it becomes a debt. Then that money has to come from somewhere. So you may find, hey, why the heck my roads are not getting repaired? Or why the heck electric pole lights are not getting repaired? Those things have running cost. So that's a very serious issue with electric buses. So what about trolley buses? Now, trolley buses are ancient. Like, they're freaking ancient. Like, this is 1800s kind of ancient. I'm not even joking. Like, they go back, really freaking back. They are very, very ancient. They are one of the earliest powered mode of rail-on-rail transport. Because, yeah, there was steam before that, but like for intercity transport, trams were, at that point in time, were only pulled by horses. So you had trams on metal wheel, on metal rail, and horses were drawing it. Everything was awesome, but it was a horse, a living thing. Why the heck you want to do that? So people want to switch. They switch to electric traction. That is the same time somebody figured out, hey, what if we remove the rail part? Because rail is expensive. Rail is awesome. It does give you all the efficiency, but does assume, again, time machine thing. You have to know where the people would be. And overhead wire is comparatively much easier. And be mindful, you have to do overhead on tram also. So you might as well, like, take care of the situation and make trolley buses. And it was made. Now, it is older than diesel buses. Let that sink in. This puppy is older than diesel buses. Buses like combustion engine buses were not a thing. Like, it was not even invented. That's how ancient this thing is. And at their peak popularity, they were like around 500 to 800 systems worldwide. Why? Because it was low cost, meaning you can deploy this system in very impoverished places also. Or you can deploy them in places that are a bit remote, but if you do not do it right now, people will start buying cars and voila, then we'll back to square one. So it was very, very successful at their peak. And capital requirement is very low and upkeep is surprisingly low, which was like these sort of things. And many of the ancient systems are still functional in Soviet, remnants of Soviet Republic and Russia and Ukraine. And many of those systems are physically not been changed from last 50 years. They're still working. That's how time tested these things are. These things are dumb, simple, they just work. Of course, you're supposed to maintain them, but if you do not maintain them or you brute force maintain it, like once it's completely broken, it can still work. It's simple. Fundamentally, it's a simple technology. So it lasts very, very, very long time. So capital requirement is very low. Upkeeps are very low. The prices of the ticket prices were very low for these things. Now, what was the weak link? If this was that successful, what was the weak link? Weak link was the poles. While the poles were early designs, of course, they were early designs. You'd never expect Mark 1 to work magically. So early poles were really not that good. And you can see that if you type basically trolley buses, many times you will see the accidents or trolley buses fails. You will see them in Russia, and many of the times you'll have the weird things where it's like pole literally falls off because it was not maintained. The poles were the weak link. So pole coming off, many people have very bad experience with trolley buses simply because of the poles were not done correctly. So your vehicle goes from a little bump and the pole comes off, meaning driver has to stop the vehicle, literally comes out and puts it back up in. The modern system of where it's automatically done, it's very recent. So pole were the weak link. Everything else was like acceptable, doable, but the pole, especially if you had a lot of vertical inclines and all that, was not done adequately, meaning we developed the pole and then we forgot about that. Hey, we have to keep improving it. Like pantograph of 1900s versus pantograph of 2000, it's completely different. But here poles more or less the same. So that was the weak link, physically the weak link. And then we had the magic combo of cheap fuel and environmental apathy, meaning nobody cared about something if they can do it cheap. This was cheaper. This was flat out cheaper than tram. So that's why people built it. That's awesome. But bus became more cheaper. Why? Because fuel became cheaper. The bus was still more expensive, but the fuel was so cheap, people did not care. So, and maintenance, flexibility, and during World War II, when Britain was getting love from Germany, a lot of the trolley buses had the issue where it's like, if the lines were broken, they can't do it. Normal bus, it can reroute. Now be mindful, the same thing applies on tram, same thing applies on metro also. So don't take it against trolley buses. But brutal aspect is environmental apathy. For example, if you have a trolley bus, how much energy it's taking to move people in the bus, it's much lower compared to even to electric bus. Why? Electric bus is carrying a huge amount of battery, and you are not carrying that huge amount of battery. So fundamentally, you're getting more megajoule used rather than, oh, I'm using the megajoule to carry the megajoule tanker, then I'm using it. So it's basically energy likes not to be converted. You just create 600 volt DC. These systems are 600 volt DC. You just dump that, it goes into the motor, it just works. No extra hassle. So they were surprisingly ahead of their time and still being used, and there are apparently 200 systems still surviving again. Recently, Nepal closed its last remaining service. India got these things, two places, Delhi and Mumbai, for a short while. We never got it like truly into the system. So that's the tragedy of trolley buses. Now, why do I classify as a tragedy? Well, problem is we are too goddamn focused on new rather than upgrading what works. For example, if I go to places and in India where it's like, hey, I want to build a metro link, that is a known technology, known cost. Again, it will take longer, but again, so does every infrastructure project. But from here to here, let's say from Mumbai to Pune, awesome. Here's the deal. If I say, hey, Mumbai to Pune metro, everybody's like, boo, no, we don't want to do this. If I say Mumbai to Pune hyperloop, everybody just starts signing checks. I'm like, dude, hyperloop is a fake scam that does not even physically exist. Everybody's like, oh, we built a small box here that goes from here to here. It's like, really? Like, if people are complaining about high-speed railways cost per kilometer wise, hyperloop cost would be so bonkers. And be mindful, hyperloop also has this another thing that it cannot physically move that many people. It's like people just write a blank check. And it happens with the same thing for, let's say, if you go to people, it's like, hey, I want to nationalize the idea that I want to put solar panel on top of parking lots. People are like, nah, no. You go to them and it's like, hey, what if I put solar panels under the road? People are like, yeah, sign me up. What if I took the solar panel, I bury it under the railway track? I'm not joking. I'm unfortunately not joking. People literally started to write checks for it. And that's the biggest issue. That's why we are not able to solve our cities, basically, is that we are too focused on new technology. This is the Nepal system. You can see that that's how simple it is. These are ancient system. If we have upgraded these things, like we could have had a proper system that even a low income capital could easily have it and grow before the cars come there. So people are used to it. So that's the fundamental issue with humanity as of now. That techno broke race that is going on, where it's like hyperloop man, solar roadway man, these things are harming us more than anything else. Like flat out, what are improvements can be done if we did improve this thing? Well, right now, if you have basically trolley bus going in one direction, if it has to come on the same road back rather than looping, it requires two wirings. Why? And not to mention a turntable, not turntable, basically a place where you can turn it, the bus. If it's a long articulated bus, it will take some space, but the wiring becomes extra clutter because you have one line for going, one line for coming out. That's the issue. How can we solve it? Well, we have modern electronics which has what we call bridge rectifiers. So you do not have to worry about the polarity. These things are DC, so you have to worry about polarity. But with modern power electronics, which is used in basically electric cars, be mindful, electric cars starts at 400 volts. Some go to 800 volt DC. So that's not even an issue. 600 volt, you're like, bro, that's basic. You go to solar companies, they're like, bro, we go to 1500 volts. That's nothing. So we can simplify the wire clutter, especially in the switching. That's the place where it has too much clutter. We no longer even have to worry about that. We have like, hey, we have bridge rectifiers. We can take care of it. And again, it does not even need to be a bridge rectifier because this will not happen all the time. So it could be just a contactor. So it's completely, efficient, because again, bridge rectifier does have some resistive loss. We can do that. Basically, modern electronics will allow much more smoother operation. Then we come to LTO cells. LTO cells are just not high capacity enough. But what if you only have to give the range 20 kilometers? Like 20 kilometers is not enough. Yes, it's not enough for a normal bus service, but more than adequate if you are being charged while you are moving. It's more than adequate enough. It's more than adequate enough tank capacity that you can do maximum loading regeneration, meaning people are fully loaded and then you apply brake at maximum power. Regeneration is like, I got this, man. You no longer even have brake dust issue. So LTO cells for regeneration, and it also allows flexibility. For example, if pole comes off, which was the biggest issue, you do not have to literally stop and come out. Your bus will literally keep going, and every bus stop, you will have a place where you can automatically relaunch it. Then it also allows another flexibility. That flexibility is going through tunnels and going through bridges. And again, bridges are seriously important because again, your weight is limited. So this solves all of those issues, because again, tunnels, you may think, we're just going to drill through those things. The moment you say that line to any contractor that deals in tunnels, they're like, yeah, write a blank check. If you just want to attach pantographs, trust me, railway engineers for tunnels, they have to spend extra time just to make sure the pantographs are tight. And same goes with bridges. Like India had 150-year-old tram system. Why the heck it did not cross the famous Howrah Bridge? The reason is the same. And not to mention, just overhead would be also expensive, and the pavement would also be very expensive. So having battery capacity that is only for 20 kilometers, even 20 is a bit much. I'm saying 20 because that's what Germany did. Germany does have a system which is utilizing the same thing, and it's surprisingly smart, surprisingly wise. So same technology, no new technology. We had this thing from like what, almost 2 centuries. We can keep using it. It's cheaper, lighter, lower running cost than EV, and it does not have the magical issue of it's like we are just assuming that we're gonna find lithium. We are just assuming we're gonna find the nickel. We're gonna assume the cobalt is ethically mined, and even titanium, like lithium titanium oxide. Titanium is not free, but here the capacity is so little. It's like, bro, it's good enough. So that's the tragedy of it. We had such a actually functionally advanced system, and we threw it away simply because little bit of convenience and little bit of apathy and this magic new shiny thing. That's the tragedy of this. This is like really sad. It's like everybody's like, we need public transport, but every transport is so expensive. But it's like, dude, we have this. We have this. It does not have the bankruptcy of an electric vehicle. It's here. It's done. Just add a small battery to it. Be mindful that many of the trolley buses does have diesel generator on them. The reason for that is many times depots could not be placed where the route is, so it had to remove the poles, go somewhere without the pole power, so it needed diesel generator. Nowadays that's not an issue. It has not been an issue from 2010. So that's why people need to know about this. People have to let go of that itch where it's like the new thing, the hyperloop hulululu. They have to let go of that itch, otherwise we all go poof. So that's why it's the tragic part of it. Like, we had such an amazing technology and we are just going round and round, round and round. So this was my presentation on trolley buses tragedy. Hopefully you have liked it, learned from it. And in that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.